I'm going to lecture on sections 9.3 and 9.4 this morning, and I'm going to use my notes for the most part. I started doing this lecture a few minutes ago, and then it just sucked, so I stopped it and decided I would just start over so that my suckiness wasn't on tape. So we're section 9.3 is a section that covers two topics. Covers perimeter and it covers area, and we don't need to know any definitions. For that matter, we don't have to have formulas memorized for this test. When you get to do this test, I'll let you use a note card, or I'll give you all the formulas that you need so that you don't have to memorize any formula. But anyways, or formulas, no definition. So a perimeter is just defined as the distance around a two-dimensional object, so it's not something in 3D. So if I drew a figure, I'll draw a nice rectangle like it's in the handout, similar. Let me say that this rectangle is, that's not probably 2 inches, but let me pretend that's 2 inches. And let me say this is 5 inches. So if I have a rectangle that's 2 inches by 5 inches, I'm assuming, because I call this a rectangle, that the opposite sides are 2 and 5 inches as well. The perimeter of this rectangle is just the sum of each of the sides. So this 2-inch side, let me abbreviate the inch, plus this 5-inch side, that's a plus sign there, believe it or not, plus that 2-inch side, plus that 5-inch side. If I add up those 4 sides, I'm going to get the perimeter. I'm going to go P equals, for P for perimeter. When I add these up, I get 2, 7, 9, 14. And it's going to be important when I'm answering a perimeter question to put units. And because this rectangle, its measurements or its distances around are in inches, I'm going to write in inches for my units. And it would be wrong had I written 14 square inches. SQ for square, IN for inches. Perimeter, the units are just linear and you don't get square units. The next concept that we have in this section is area. And the area of a figure is defined as the number of square units that will cover the figure. And for my rectangle above, I could hypothetically draw rectangles that are theoretically equal in size to tell me what the area of this particular rectangle is. So I'll try to draw this out. So I can cut the sides into 2 pieces for each inch, and I can cut the horizontal sides into 4 pieces. Theoretically, I've used a ruler and all these squares are equal amounts, distances, but they're not. But assuming that each one of these squares is a 1 inch by a 1 inch, this particular rectangle has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, hypothetically 1 inch by 1 inch squares that will cover it. So the area of, the area of that rectangle, I would say, is 10 square inches, because each one of these squares is hypothetically 1 square inch because it's 1 inch by 1 inch. So the number of squares, units that will cover a figure, implies that when I'm writing down the area of a figure, I need to say the number of square inches. So the area of that rectangle is, I'll say it's 10 square inches, and I'm abbreviating a little bit, SQ for square, IN for inches, assuming that you are familiar with those. If not, yell at me and I'll try to clean this up when you come to class. So most every problem in the section that I picked for homework is basically just computing areas. And in order to compute areas and perimeters, in order to compute perimeters, you don't need a formula, you just need to know the lengths of all the sides. But in order to compute an area, you have to have some formulas. And I printed up a bunch of formulas, and for area and perimeter, honestly, you don't really need a formula for perimeter, because you can, as long as you know the lengths of each of the sides, you can get the area. And then circles are a little asterisk, because circles we really don't have perimeter. For circles, the word perimeter is replaced by circumference. So you'll never see somebody ask you to find the area of a circle, or the perimeter of a circle. So for circles, if they want me to find the perimeter, they'll ask me to find the circumference. When I get into circle problems in the book, I will talk about some of these letters, just in case you don't remember those. So let me dig into the book a little bit and do a couple problems from the book and see how that goes. So the homework asks me to do a bunch of area problems. You're probably going to, and perimeter problems. You're probably going to want to have your calculator handy, unless you're just really calculator savvy. So I'm going to do a bunch of the even problems that are on this page in the book. So this is the beginning of section 9.3. And I'll start with number 6 here, assuming I assigned most of the problems in this section. So when I go to find the perimeter of a triangle, I have to sum up the lengths of all 3 sides. And the author was evil here and didn't give me all 3 sides, which means I need to do a little hiccup and go back to my notes before I get into the text, because I can't find the perimeter of a triangle unless I know all 3 sides of the triangle, and I can't know all 3 sides of the triangle unless, oh, duh, man, this is just a sucky video. Back up. I only need to find the area of the triangle, not the perimeter. I don't need to back up. I thought I was going to have to introduce the Pythagorean theorem, the a squared plus b squared equals c squared, but I don't, because when I read the instructions closely, the author says just find the area of the triangle. So if you don't know the area formula for the triangle, so I don't have to go backwards here, you can go to page 498, and the author has given me a picture of a bunch of figures along with their formulas, and the formula that I'm going to need for this problem is area equals 1/2 BH. B means base, H means height, and in a triangle, the base and the height are sides of the triangle that are connected to a right angle. So in this particular triangle, I see 2 sides that were given. I'm going to use the area formula. Area equals 1/2 the base times the height. And I'm going to call the base this 1 foot, because it's at the bottom, hence the base, and it's connected to a right angle. So when I go to do the area here, I'm going to say it's 1/2 times 1 feet. I'm going to call this side the height. It looks like it's going high and it's connected to a right angle, so that's good. And notice the author says this is 3 yards. If I put 3 yards into my formula, I've got my units aren't matching up. I need to convert the 3 yards to feet and leave myself a lot of room here. So I'm going to cheat and just multiply this in my head. I know that 1 yard is 3 feet. So to change 3 yards into feet, I'm going to multiply 3 yards by the fact that 3 feet is 1 yard. The yards will cancel and I'll be left with 9 feet. So the side that I'm calling the height, I'm going to call 9 feet. Now I'm going to do this multiplication. I'll just break my calculator out to do it. And I'm going to give a decimal answer. I'm going to live with a decimal just fine. So I'm going to put the 1/2 in a parentheses. I'm going to go 1 divided by 2 for the 1/2 times the 1 times the 9. I can't put the units on my calculator, so I'll get those units put in later. When I do that multiplication, I get 4.5. So I'm going to write A for area equals 4.5. And then the units are feet times feet. I'm going to write square feet. So I'm going to write SQ for square and then feet. I could have converted this side 1 feet into yards, but then I would have got an uglier answer. So that felt like a good thing to do. When I go to do the next even problem, I'll save the odd problems for you. It's another triangle. I'm asked to find the area for it. And in this case, the author drew something in for the height. It's not one of the legs of the triangle. A height is defined as a line that goes from one of the corners to the opposite side that forms a right angle. And that line, the H for problem 8, is supposed to be the square root of 3. This side is supposed to be the base. If you look at this triangle, the author has these little tick marks across the triangle, and that means that all of those sides have the same lengths, and very specifically, the base for this particular triangle is going to be 2 meters. So when I go to do the area for this particular triangle, I'm going to say the area is 1/2 times the base. I'm going to put the units with the base, which is 2 meters, times the height, and I'm going to put the units with the height. It's going to be the square root of 3 meters. So the area for this is 1/2 times 2 times the square root of 3. The units are going to be meters times meters are meters squared. So when I go to write my answer, I'm going to write area equals, and then I'm going to write SQ for square, and then M for meters. If you wanted to, you could have wrote the M with an exponent of 2 to mean square meters as well. And then I'm going to get my calculator out here to get the number. So I'm going to go parentheses 1 divided by 2 for the 1/2, and then times 2, and then times square root of 3. And on my calculator, to get the square root of 3, I'll hit the second button, and then the x squared key. And now I'm going to type the number 3. The calculator inserted a parentheses, a left parentheses. I'm going to close my left parentheses with the right parentheses. And I'm going to get an answer that's not very nice in terms of decimals. The author didn't say anything about rounding. I'm going to round to 2 decimals. And on the test, if we get a decimal answer, I'm going to tell you how far to round. So the area of that triangle is 1.73 square meters. If you're doing all the homework problems, it may not be super obvious what the base and the height are. In problem 7, the height is supposed to be this 5 centimeters. The base is supposed to be the 7 centimeters. And in problem 5, the height is supposed to be the 7 inches, and the base is supposed to be the 10 inches. So now I'll get to the next group of problems. The next group of problems, I have to understand what shape is given to me and know the formulas that are necessary to find what the author wants. In problems 9 through 14, the author wants me to find the area and the perimeter and of the quadrilateral. A quadrilateral is just a figure that has 4 straight sides. So each one of these are 4-sided figures, so they're quadrilaterals. The first one's a rectangle, and I have the formula for the area of the rectangle memorized. It's just length times width. And I usually make the longer side and I call it a length, and the shorter side I usually call the width. But there isn't it wouldn't be wrong if I called the 15 a width and the 7 a length, it would be okay. But it's just fine to do what I did. So the area is going to be the length, which is 15 feet, times the width, which is 7 feet. There's no 1/2 in this, which is nice. I'll just multiply the 15 and the 7, and I get 105. And my units need to be square feet. So next to the 105, A will stand for the area. I could write out the whole word square feet. I could write a SQ then a feet like I did over when I did problem 6. I'll do something that's equivalent just so you can see some different representations. I'm going to write feet squared. So the area of the quadrilateral on number 9 is 105 square feet. The perimeter I can get by using a formula if I want to have another formula memorized, or I can just add up the length of each of the sides. Because I'm assuming this is a rectangle, there's some sides that aren't marked that are assumed. And so I'm just going to add up the 4 lengths. So one side is 7 feet, and then I have another 15 feet, another 7 feet, and then a 15 feet. When I add up 7 plus 15 plus 7 plus 15, I get 44. And it's just going to be feet. So the perimeter of the quadrilateral or the rectangle on number 9 is going to be 44 feet. The area is 105 feet squared. The figure in problem 10, it's a parallelogram. And if you don't have the formulas memorized for the area of a parallelogram is the base times the height. A height is a length that goes from one of the corners to the other side that forms a right angle. So this 5 is considered a height. And the 7, because it's on a side that connects the height, is considered a base. I'm assuming that all 4 sides have the length, well, the sides have the lengths of the opposite sides. So for this, because this is a parallelogram, the area formula is base times the height. And for this particular problem, the base is 7 inches, the height is 5 inches. If I multiply 7 inches by 5 inches, I multiply inches by inches and I get square inches. I'm going to write an IN with the exponent 2 to mean square inches, and the 7 times 5 is going to give me 35. So for problem 10, for that particular parallelogram, the area of that parallelogram is 35 square inches. The perimeter, I'm just adding up the sides. The height isn't considered one of the sides, so I'm going to take the 6-inch side plus the 7-inch side plus the 6-inch side plus the 7-inch side. So we'll go 6 inches plus 7 inches plus 6 inches plus 7 inches. My units are just going to be inches. When you're adding, you don't get square units. If I add up those 4 numbers, I get 26 inches. So for problem 10, that parallelogram has an area of 35 square inches. It has a perimeter of 26 inches. Let's skip down and do 12. 12 gives me a square, and the units aren't the same. When I go to do area or perimeter, I want to have the units the same, and I don't. It's easier for me to change yards to feet, so I'm going to do that before I do my computation. So the 2-yard side, I'm going to multiply by the fact that 3 feet is 1 yard. Yards will cancel. I'll multiply the 2 and the 3 and get 6. So I'm going to change this to 6 feet. It's a square, so the sides should have the same length. The area for a square, the formula is side squared. So the area for this particular square is going to be 6 feet squared. And that means 6 feet times 6 feet. So for this figure, this square, the area is going to be 6 times 6, which is 36. in square feet, and now I'll write SQ feet just so you can see a variety of forms for the answer. The perimeter, I can add up the four sides. I believe if you looked in the formula, the author would say the perimeter is 4s. So instead of adding 6 plus 6 plus 6 plus 6, you could just multiply 6 by 4 and get the perimeter. So to find the perimeter, it would be okay just to go 6 feet plus 6 feet, and then these sides are also 6 feet. So 6 feet plus 6 feet plus 6 feet plus 6 feet. That will give me 24 feet. Or if I just did 4 times 6 feet, I'd get 24. I wouldn't get square feet because there's not 2 feet there, and it's just going to be 24 feet. Again, if you don't have a formula for an area or perimeter memorized, then you can just turn to page 498, and it'll give you that formula that you're going to need. So I'll do a few more even problems just because you may have forgotten how to find some basic area figures. And I'm going to do number 14. So 14 gives me something that's called a trapezoid. Trapezoids have one set of parallel sides, like probably spell that properly so I don't look like a fool. So it's trapezoid. And real quickly, the picture that I see on page 498 that I'm copying right now gives me a picture like with a bunch of labels. It has an S1, which means side 1, an S2 means side 2, an H means a height. It has a B1, which is base 1, B2, which is base 2. The perimeter formula that the author gives me, which is kind of overkill, the author says I just have to add up the 4 sides but not the height to get the perimeter. And the area formula is more complex. It's 1/2 times the height plus the sum of the bases. So in order to find the answers to the perimeter and the area of the figure given in problem 14, I need to take that figure and determine each of the pieces. It's an upside down trapezoid, but that's okay. This figure, this dashed line that I'm drawing in first, that's measured at 12 inches, that's the height. So in this particular, the only time I'm going to need that is in the area formula. I need that height. And then the 4 sides are given to me. I see a 6-inch. I'm going to call that base 1. It wouldn't be wrong to call it base 2. And the 16 inches up top, I'm going to call that base 2. So as I label my sides, I call it 12 the H, the 6 I'm going to call base 1, but it wouldn't be wrong to call it base 2. The 16 I'm going to call base 2. And then the other sides, the 13 inches I'm going to call, just because this is flipped over, I'm flipping everything. But it doesn't matter. The S1 and the S2 are interchangeable. If I called that S1 and that S2, it wouldn't matter. Similarly, if I called that B1 and that B2, it wouldn't matter. So the perimeter, I'm adding up the 4 sides, but I'm not taking the height. So the perimeter is side 1, which is 13 inches, plus side 2, which is 13 inches, plus base 1, which is 6 inches, plus base 2, which is 16 inches. The number I'm going to get, the unit I'm going to get is just inches, because when you're adding, you don't get square inches. When I add up these numbers, 13 plus 13 is 26, plus 6 is 32, plus 16 is 48. So the perimeter of that figure is going to be 48 inches. The area is going to be 1/2 times the height. That's the only number I haven't used yet. So it's going to be 1/2 times 12 inches times base 1 plus base 2, which is 6 inches, plus 16 inches. Orders of operations force me to do the parentheses first. So I'm going to have 1/2 times 12 inches. And the parentheses, I'm going to add the 6 and the 16 and get 22. And when I'm adding, I don't get square units. So the parentheses simplifies to be 22 inches. And now I'm going to do the multiplication. I'm going to multiply the units. Inch times inch is going to give me square inches. And then I'm going to multiply 1/2 times 12 times 22. And on my calculator to do that, I'm going to go parentheses 1 divided by 2. So put the 1/2 in a parentheses. And then times 12 times 22. And I get 132 for the number. And our units are square inches. So for the trapezoid given in problem 14, the area is 132 square inches. I don't know if I could just keep working in the book, but I think I can, and I will. So as I keep working in the book here, so I've kind of strayed away from my handout quite a bit, but I didn't think I needed my handout so much. The next shapes in my handout are circles, and the author wants me to find the area and the circumference. So I'll do problem 16. 16 gives me a circle, and the 100 centimeters is considered a diameter. The distance through the center all the way across the circle is considered a diameter. And when I dig out the formulas, that's going to represent a D in my formula. I might need an R. So when I work with this particular circle, the R is the distance from the center to one of the sides, so it's half the diameter. And that R, the distance from the center to one of the sides, is called the radius. So for this particular circle, before I dig out my formulas, it might be the case that I need to know the diameter, which is the distance through the center all the way across, or the radius, which is the distance from the center to the one of the sides. The radius is that distance from the center to one of the sides. It's always half the diameter. So now I'm going to pull out an area formula. And circles don't have perimeters. Well, they have perimeters, but we call the perimeter circumference. And now I'm going to do the circumference as well. And again, if you don't have those formulas memorized, you don't need to have them memorized. Our author gives those to you somewheres in this section. Somewheres in this section, I'll stumble across a formula for circles, and the author just puts it in microscopic here. It says the circumference is 2 pi r, which is, and I'm going to use 3.14 for pi, and because our author says, recall that pi is approximately 3.14. It says if your calculator has a pi key, you should use that key when working with calculations. I'm just going to use 3.14 for pi, and the area formula is pi r squared. So both the formulas that the author gave me that I'm going to need for this circle have the radius in it. So the radius formula, the area formula, the author is going to give me pi r squared. Their circumference formula is 2 pi r, circumference being the perimeter for this. And I'll just answer this. So area, I'm going to write A equals to pi. I'm going to cheat and write 3.14 for pi. And then r squared, that's going to be 50 centimeters squared. And I should remember that squaring something is equivalent to multiplying it by itself. So the area is going to be 3.14 times 50 centimeters times 50 centimeters. And I'm going to give an answer that has 2 decimals worth of accuracy. Let me peek in the back of the book and see what kind of answer the author gave for the odd problems in this section in terms of how the author presented his answers and how he rounded. Just so if I'm being wildly inconsistent with the author, I can talk about how to compare your answers to the author answers. When I look at the author's answers to like problem 17, the author rounded to 2 decimals, so I'm going to round to 2 decimals. So I think using 3.14 for pi is going to be perfect, and I'm going to take my answer and round it to 2 decimals. The author didn't say in the instructions to round to 2 decimals, but I'm just defaulting to that because I peeked at the answer for the odd problem that's right next to this in the back of the book. So I'm multiplying 3.14 times 50 times 50, and that's going to give me the area. So I'm going to write A for area, and amazingly I get 7850, no decimals, square centimeters. If this was a test, I would be completely content with that answer. If you wanted a slightly more accurate answer, I'm not requiring that. But if you use the pi button on your calculator, if you did pi times 50 centimeters times 50 centimeters, you'll get an answer that looks a little bit different. For me to activate the pi button, I hit my blue second button and then the up arrow key. So I'd go second and up arrow, there's the pi, and then times 50 times 50. And when I hit enter, you'll notice I get a slightly different answer. So I'm going to be very flexible when I'm grading your tests, realizing that if you use 3.14 for pi, you'll get a slightly different answer than if you use the pi button. And we're just not doing any computations that need to be ridiculously accurate. So I would take each, but notice how different the answers are. I use my calculator both. One, I use the pi button, which has way more than just 2 decimals, says infinitely many decimals. And using the 3.14 for pi, you get a slightly different answer. So if you're doing circle problems and you're checking your answer to the back of the book and it's slightly different, then your difference has more than likely to do with what you use for pi. You use something different for pi than what the author used. So that is the area part of number 16. So I take either 7,850 square centimeters or 7,853.98 square centimeters. And now the circumference, I'll have the same deal. If I use pi for 3.14, I'll get a different answer than if I use the pi button. But nevertheless, to do the circumference, the formula is 2 pi r, so I'm multiplying 2, and then something that represents pi, and then times the radius. The units, because there's only 1 centimeter, it's not going to be square centimeters, it's just going to be centimeters. And I'll do both computations. If I did 2 times 3.14 times 50, I'd get the circumference is 314 in just centimeters. It's not centimeters squared. If I did the same computation and did my pi button, I'd get 314, and I'm going to round this to 0.16 centimeters. I looked at the number in the second decimal place, which is a 5. That's the number that I wanted to round. I was either going to leave it a 5 or round it to a 6. I looked up the number after the 5, which is a 9. It told me to round the 5 up to a 6. So either one of these answers for the circumference of the circle in problem 16 are suitable. I'm going to skip doing 18 and 19, assuming you could do these the same way. I'm going to do a few more of the area problems in the section before I dig into the triangle problems. Problems 19 through 22 on this page are Pythagorean theorem problems, the a squared plus b squared equals the c squared, and I'll do those in a bit, but just not right now. So as I get into the text a little bit deeper, the next group of problems, 23 through 32, are area problems, and they're hard area problems because I'm only asked to find a shaded region, and this requires me to be a little gifted geometrically to understand what the area is. So like if I look at problem 24, which is on the bottom of this page, the area that I want is the area, here there's a circle drawn inside a square. I want the area part of the square, not including the circle. To do problem 24, I have to know visually what I'm finding, and the area, the region that this is finding, these regions here, are what's left when you take the area of the square that's drawn here, and I'm assuming that the circle has a diameter of 10 meters because it has a radius halfway across the circle is 5 meters. The whole way across is 10 meters. So this circle has a radius of 5 meters, a diameter of 10 meters. The square, I'm assuming, is a 10 by 10 square. And to get the shaded area, I need to take the area of the square and subtract from it the area of the circle, because that's what this picture shows me. It shows me a square with a circle drawn inside of it, and I'll just do that right now. The area of the square area is side times side, or side squared. The area of the square is going to be 10 meters squared. The area of the circle is pi r squared. I'm going to use 3.14 for pi. I'm not going to do both computations. And then r squared is going to be 5 meters squared. If I do this computation, the area of the squared, which is 10 meters times 10 meters, which is 100 square meters, minus the area of the circle, which is pi r squared, which is 3.14 times 5 meters times 5 meters. When I do those computations and subtract the results, I get the area that I'm looking for. And for the circle, I'm going to write 78.5 meters squared. And now I'm going to subtract these, and I'm going to be lazy and use my calculator. The shaded area is going to be 21.5 is going to be the units. And because it's area, it's square units. So the shaded area in problem 24 is 21.5 square meters. Now I'm going to go up to problem 26. I'll do 26. I'll do 28. I'll maybe attempt 30 as well. So 26, when I look at it, I see a trapezoid inside of a rectangle. So as I look at 26, if I try to blow it up, I see a rectangle. I'm assuming the rectangle is 7 feet by 4 feet. And then the author draws something like this, and I see a trapezoid inside the rectangle. The dimensions of the trapezoid, the height is going to be the 4 feet. That's the distance between the sides. And each of these sides, I'm not going to write it, I can see it up there, it's 4.47 feet. And the author also sneaks a base 1 and a base 2. This I'm going to call the base 1. This I'm going to call the base 2, this little distance, which is this 3 feet. Pictorially, the shaded area is the area of the rectangle minus the area of the trapezoid. Most of these problems, the shaded area I'm going to get by subtracting, and that's the case here. So for this particular rectangle, the formula for the area of the rectangle is the length of the rectangle times the width of the rectangle. The rectangle is 7 feet by 4 feet, so its area is going to be 7 feet times 4 feet, which is 28 square feet. And then when I do the area of the trapezoid is going to be 1/2 the height times base 1 plus base 2. And half the height is going to be half of 4 feet. And then base 1 plus base 2 is going to be 7 feet plus 3 feet. So it's going to be 1/2 of 4 feet, and then 7 feet plus 3 feet is 10 feet, so it's 1/2 of 4 feet times 10 feet. I could do that without a calculator, but if you needed a calculator, it's fine. It's going to be 20 square feet. So this is going to be the area of the rectangle, which is 28 feet squared, minus the area of the trapezoid, which is 20 square feet. The shaded area is going to be 28 minus 8, 28 minus 20, which is 8 square feet. So it would be wonderful if you took a few minutes and tried to do some of the other problems that are here. But if you can't, that's fine. You can just watch me do them. The next problem I'll do is 28. And in 28, I want to find the shaded area. And in 28, the shaded area is going to be the area of the circle minus the area of the rectangle. If I look at the rectangle, inside this circle, this rectangle, I'm assuming its length and its width are 6 meters and 8 meters. I see a 6 there and an 8 there. So the area of the rectangle is length times width. That's the area that I need to subtract out, and that's just going to be 6 meters times 8 meters, or 8 meters times 6 meters. The area of the rectangle is 48 square meters. The area of the circle is pi r squared. I see the 10 meters as the diameter. Half the diameter is the radius, so the radius is going to be 5. The area of the circle is going to be pi, which is 3.14, times r squared. That's going to be times 5 meters squared, because the area of the circle is pi r squared. The r is the distance halfway across the circle, which is half the diameter, which is going to be 5. So this is going to be 3.14 times 5 meters times 5 meters. And as I do this, I get 3.14 times 5. I get 78.5, and I'm going to write square meters. So the area of the circle is 78.5 meters squared. If I subtract the area of the rectangle, I get the shaded area. So I take the 78.5 minus 48. The shaded area is going to be 30.5. I'm going to write my units. So my shaded area is going to be 30.5. I'm going to write square meters again. 29 looks really involved. I promise you that I don't have the ability to draw something like 29 with my computer. At least I don't know how to do it, so it wouldn't make its way onto the test. So I'll do 30 last. So 30, the picture looks something like this. There's a big circle, and inside it are 2 small circles. I'm assuming that the distance all the way across from one edge to another are the diameter of the big circle. As what the author gave me here as 28 centimeters. So that would mean the radius of the big circle is going to be 14 centimeters. So the distance from the center of the big circle to the edge is 14 centimeters. So the radius of the large circle is going to be 14 centimeters. And then, if I look at the little circles, I'm assuming that each of the little circles has a diameter that's equal to the radius of the big circle. So for each little circle, I'm assuming that this distance right there, its diameter, is 14 centimeters. So the radius of the little circle is half of that, which is 7 centimeters. And the shaded area, if I look at the book, is going to be the area of the big circle minus the area of the 2 little circles. So the shaded area that I'm trying to figure out it's going to be the area of the big minus the area of one of the smalls minus the area of the other one of the smalls. If you're slick and you realize those 2 small circles have the same area, you could just do the computation once and subtract, or multiply by 2, should I say. So the area of the big circle, it's pi r squared. I'm going to write 3.14 for pi. The radius of the big circle is 14 centimeters. So I'm going to do 14 centimeters squared. Now I'm going to go to the area of the small, which is going to be 3.14. And I'm going to do times 7 centimeters squared. And the area of the next small circle is 3.14 times 7 centimeters squared. Let me compute each one of these numbers. So the first one I'm going to do a little bit slickly. I'm going to go 3.14 times, and I'm going to go 14 and hit the squared key. And that's going to give me the big circle's area, which is 615.44. I'm going to write centimeters squared. And then each of the little circles, I'm going to go 3.14 times 7 squared, and I get 153.86 for each one of those. And each one of those is going to have units of centimeters squared. And when I do that computation, 615.44 minus 153.86 minus 153.86, I'll get the shaded area. And the shaded area is going to be 307.72 centimeters squared. So each of the problems where the author gives me a figure that has shading in it. I have to determine conceptually what the shaded area represents, and the shaded area is always going to represent a subtraction of areas. And you have to figure out which areas need to be subtracted to get the area that you want, and then you need to find the individual areas that make up the big and the small figures. All right, so that's little bit of problems. I think I can do the last few problems, and then I'll get back to my handout. I thought I was going to lecture specifically using my handout, but then I just didn't feel the urge as I started lecturing here. So 2 more banks of problems to do that we have to worry about. We have to worry about these problems between 33 and 36, and then 37 and 40. These are easy problems because they tell me I'm just converting. If I look at the problems in the book, the problems on the top of page 505 tells me that 1 square yard, so 1 yard squared, equals 9 feet squared. And problem 34 asks me to convert from 15.2 feet squared to, I'll abbreviate, yards squared. Not hard to do this at all. I just take what I start with, which is the 15.2 feet squared. I'm going to multiply by a unit. And the numerator is the unit that I want. I want yards, so I'm going to put yard squares in the numerator. In the denominator, I'm going to write the unit that I'm trying to get rid of. I'm trying to get rid of square feet. And to do this, I'm just going to go 15.2 divided by 9 because the 9's in the denominator. The number I'm going to get is 1.688888. I'm going to round that to 1.69. The author, again, doesn't take the time to tell me to round or not round. So I'm going to round that to 1.69 because I got 1.68 and then a bunch of 8s. The 8 in the third position tells me to round the 8 in the second position up. And my units are going to cancel. Feet squareds will cancel with feet squareds. And I'm left with a unit of yard squared. I'll do 36. I won't even do 37, 38, 39, and 40. They're exactly the same. The units in the next group of problems says that 1 square meter, that's 1 meter squared, equals 10,000 centimeters squared. And you're going to do those identically the same way that I just did the problem that I started with. So let me sneak 36 in. 36 wants me to convert from 18.3 yard squares, square yards, to square feet. I did SF for square feet, but I could have said feet squared. So I'm going to start with the 18.3 yards squared that I have, and I'm going to multiply by the unit. In the numerator, I'm going to put the unit that I want, which is feet squared. In the denominator, I'm going to put the unit that I'm getting rid of, which is yards squared. And then the author tells me that 9 feet squared is equal to 1 yard squared. I can cancel my yard squareds. My units are going to be square feet. And the 18.3 gets multiplied by the 9 because the 9's not in the denominator. So the number I'm going to get, I'll go 18.3 times 9 is 164.7, and the units are square feet. So that takes us through most everything that I assigned in the section, other than the bank of problems between 19 and 22, which are Pythagorean theorem problems. And let me do a few problems from my notes, being that if you printed out the notes, it feels horrible that I didn't use any of my notes to do this section. So getting back to my notes, I didn't do much from my notes, but the next page of my notes gives me a bunch of pictures of triangles and even shows you how to use the Pythagorean theorem unless you forgot. So in a triangle that has a 90-degree angle, or a right angle, the formula a squared plus b squared equals c squared, the Pythagorean theorem shows. And in this particular triangle, the C is always the side opposite the right angle. So this side that's drawn as H, I'm going to call the C. The other sides, A and B, are it doesn't matter what you call each. I'm going to call 6 because it's shorter the A, and 8 because it's longer the B, but it really doesn't matter. And the Pythagorean theorem says a squared, in this case, which is 6 squared, plus b squared, in this case, which is 8 squared, equals c squared. In this case, I could have written h squared, but I like the c better. These squaring I could do in my head. 6 squared is 6 times 6, which is 36. 8 squared is 8 times 8, which is 64. C squared, I'm going to leave as c squared. Now let me get to my calculator. Let me do 36 plus 64. 36 plus 64 is 100. So I get 100 equals to c squared. To find out what c is, I need to take the square root of it. So if I know something's squared, I square root to get it. To do square roots, I go second, the blue second button in the x squared key. Then I type the number I want to take the square root of, in this case 100. And I hit enter, and it tells me 10 equals to c. Because this is a length, it's not going to be square units. It's just going to be like 10 inches or 10 meters or so forth. I'll do each one of these problems because just so you can get familiar. So in this next triangle, this 15, because it's opposite the right angle, I call a C. I'm going to call the 9 the A, and the X I'm going to call the B. And I'm going to solve for that X. I'm going to call it a B. I'm going to go A squared, which is 9 squared, plus B squared, or you can write X squared there if you care to, equals C squared, which is 15 squared. 9 squared is 9 times 9, which is 81. B squared, I'm going to solve for it in a second. 15 squared is 225, but on my calculator I can go 15, hit the x squared key, gives me the 225. There's a bit of algebra to do here. The algebra is minusing 81 from both sides and then square rooting. When I minus 81 from both sides, on the left side the 81s cancel, I'm left with the b squared. On the right side, 225 minus 81 apparently is 144. And now I'm going to square root both sides. I'm going to square root and square root. The square root of b squared is b. The square root of 144, I go second in x squared on my calculator, type 144. Could close the parentheses, I really don't have to, and I get 12. So the b, or in this case the x, is the 12 units that the author wants me to have. You could read these two examples just fine, I suppose. So if that review wasn't enough to get you comfortable with the Pythagorean theorem, then you could read those two. I'm going to go back into the text a little bit here and do some problems. So I really kind of shorted you a bit on these problems, but that's okay. So let me look at the problems between 19 and 22. Numbers 19 through 22, the author gives me a picture of a triangle. Number 20, the triangle looks something like this. Not the ultimate best drawing, but it's good for me. And the author says one side is 5 feet, the other side is 12 feet. Nice enough to call this side a C. And the instructions say do A, find the unknown side. That's the C in this case. And then after I've solved A, do part B, find the perimeter of the triangle, and do part C, find the area of the triangle. So I'm going to use the Pythagorean theorem. I'm going to call the 5 the A, the 12 the B. I'm going to go 5 feet squared plus 12 feet squared equals C squared. Use my calculator. I'm going to dump off the units because the units work their way out. So I'm just going to write 25 here instead of 25 square feet. And for the 12 squared, I'm going to write 144. And again, I'm dumping out the units just because I think it's easier. I'm going to add the 25 and the 144. And that gives me 169 is c squared. I'm just going to take the square root of that. So I'll go second square root 169. And that's going to give me the 13. That is what c is. So the missing side in this is c is 13. Because the other sides have units of feet, this side is also going to have a unit of feet. So I kind of cheated and didn't put my units in because it maybe got more complicated than it needed to be. The perimeter is just adding up the sides. So I'm going to add up, so for the perimeter, I'm going to say it's the 5-foot side plus the 12-foot side plus the 13-foot side. When I add those three numbers up, I get 30. And the units are going to be just in linear feet, not square feet. And then the area is 1/2 times the base times the height. In this particular problem, the base and the height need to be the sides that hook up with the right angle. I'm going to call the A the base and the 12 the height. So when I do the area for this triangle, it's going to be 1/2 times 5 feet times 12 feet. And I can do that computation in my head. If you can't use your calculator, I'm going to get 30 square feet. Let me do one more problem, and I'll do problem 22. So 22 gives me another triangle, wants me to find the unknown side, the perimeter, and the area, and the author was very nice, told me that the unknown side is the B, gave me the C, which I'm going to call this the C, gave me the A, I'm going to call that the A, and wants me to find the B. So first I want to find the unknown side. I know that A squared plus B squared equals C squared in the right triangle. For A squared, I'm going to do 15 squared. I'm going to dump off the units. I was tempted, I started to write the units, but I just scribbled them out. Plus B squared, I don't know, equals C squared, which is 39 squared. Definitely calculator worthy. So I'm going to go 15 squared is 225. 39 squared is 1521. So this is going to be 225 plus b squared equals 1521. I'm going to minus 225 from both sides. On the left side, if I minus 225, the 225's cancel. I'm left with a b squared. On the right side, I have to go 1521 minus 225 to do that subtraction, and I get 1296. And then I'm going to take the square root of that. So I'm going to go second and x squared, type in 1296. I get 36 for my missing side. Because the other sides have units in meters, I'm going to say this side is in meters as well. So that's the hard part. Part B wants me to do the perimeter. The perimeter, I'm just going to add the sides. The sides I see are 15 meters plus 36 meters plus 39 meters. So the perimeter is going to be just in meters, not in square meters. I'm going to go 15 plus 36 plus 39, and I get 90 meters. Last part is the area. Area is 1/2 the base times the height. I'm going to call this A the height because it's connected to the right angle. I'm going to call the 36 the base. When I do 1/2 the base times the height for the area is going to be 1/2 times 36 meters times 15 meters. And on my calculator, I go parentheses 1 divided by 2 for the 1/2 times 36 times 15, and I get 270 square meters. And I'm going to write meters squared for my answer. So that's everything that is going to make its way into the homework for section 9.3. So I think I'll stop and pause the video there. I kind of wanted to do 9.3 and 9.4 in one video, but I feel like this was long enough already that I would just maybe do 9-4 another day. So let me look at 9-4. Yeah, I'll just do it another day. All right, so that's at least 9-3, and then you'll get to watch 9-4 when I get it done. Thanks.